given question, find magnitude, direction and point of application of the resultant for the given system. We have to find out magnitude, direction and point of application of the resultant for this given system. If we observe, two arms are pivoted about this point O. We will first resolve the forces in horizontal component as well as vertical component. Now the 700 Newton is horizontal force, 1200 Newton is vertical force, 1000 Newton is also vertical force. Now we will resolve this 500 Newton force in horizontal component as well as vertical component. So for this horizontal component we can write here 500 cos of 60 and here 500 sin of 60. We will first find out the horizontal component of the resultant, that is Rx, and vertical component of the resultant, that is Ry. So how to find out Rx? So for this given system, summation of all horizontal component of forces is known as Rx. So we will add all the horizontal forces for this given system. So Rx is equal to summation of Fx, which is equal to. Now for this case direction is important. Now the forces which are towards right hand side direction we will consider positive sign. And the forces which are towards the left hand side direction we will consider negative sign. So first force is 500 cos of 60, we will give here plus sign. Second force is 700, we will give here the minus sign, that is minus 700. So answer is minus 450 Newton. So how we will write this in terms of direction? So here is negative sign, so we will give the direction towards the left hand side. Now we will move to calculate Ry, that is the vertical component of the resultant. So we have to add all the vertical forces. Now here also we have to consider the sign. So for the downward direction we will consider negative sign and for the upward direction we will consider positive sign. Now if we observe 500 sin 60, we will give negative, that is minus 500 sin 60 minus 1000 minus 1200 Newton. So answer is minus 2633 Newton. So in terms of direction, because of negative sign we will give downward direction. Now we will find out magnitude of resultant R. So for this case we can find out the value with the use of this Rx and Ry. So under root of Rx square plus Ry square, that is equal to resultant magnitude of resultant R. So under root of 450 square plus 2633 square, and which is equal to 2671.2 Newton. So this is the magnitude. Now we will find out its direction. So how to find out? So first I will plot the direction of the resultant R. So Rx direction is towards left hand side, magnitude is 450 Newton. So I will take here direction is towards left hand side and here is the horizontal component of resultant R. Now what about vertical component? For vertical component direction is in the downward direction and magnitude 2633 Newton. So it is greater than 450 Newton. So I will draw one vertical line. So its scale should be larger than this Rx. So here is in the downward direction, here is Ry. So this is the horizontal component, this is the vertical component. So I will take here, how to complete this R. So how to decide the value of R. So if I draw one line parallel to Ry at the end point of Rx and here one line parallel to Rx from the end point of Ry, then here is the point of intersection. Now if I join these 2 points, that is this point of intersection and this point of intersection of Rx and Ry, then we will get the R. So this is the resultant R. Now how to find out the direction? So we will find out the angle alpha in between this R and Rx. So if I draw here alpha. So how to find out alpha? So we can say that here is the triangle. So I will say here is point A, B and C. In triangle ABC, tan of alpha is equal to, now this vertical line magnitude is equal to Ry. So tan of alpha is equal to, I will write here, Ry divided by Rx. So Ry we have calculated, we have to consider magnitude only, 2633 divided by Rx, Rx 450. So alpha is equal to tan inverse of 2633 by 450, which is equal to 80.30 degree. We have to find out point of application of resultant R. So we will take approximate distance x from this point O and we will plot this resultant R. So I will draw the same direction of the resultant R. Now if we observe this diagram, then this horizontal component Rx and this horizontal line both are parallel to each other and both are having same direction. So this is also known as Rx. And this vertical line and this vertical component both are parallel to each other and both are having same direction. So if I draw this, then here is this component Ry. So we will show this Rx, Ry and this resultant R. Now this angle alpha, if we observe, both are the opposite angle. So angle in between this R and this Rx is also known as alpha. And it is equal to 80.30 degrees. So I will draw here R at an angle alpha. Now we will show the same horizontal component, that is Rx, and here same vertical component in the downward direction, that is Ry. Here is the angle alpha. Now this is the point of application of resultant R. Now we have to find out this distance, and this unknown distance from this point O, we will consider this distance is x. And we have to find out this unknown distance x. Now we will apply the Varignon's theorem, or it is also known as moment principle. According to Varignon's theorem, the moment of all the forces about the moment center O is equal to moment of resultant about the same moment center. So we will first take the moment of all these forces about the moment center O. So first we will consider 500 Newton. Now for this 500 Newton is having two components. First, horizontal component. Now if we observe, the horizontal component is passing through the point O. So perpendicular distance is 0. And for this vertical component, perpendicular distance, if we observe from the point O, is 150 plus 150, that is 300. So how we can decide? It's a sign. Now if we move the compass about the point O in the direction of 500 Newton, that is in the downward direction, then here is, this is the anti-clockwise direction, and for this direction we will consider negative sign, and for clockwise direction we will consider positive sign. So here is the anti-clockwise direction, so we can say that its value is 500 sine of 60. So minus 500 sine 60 multiplied by 300. Now we will move next, force 1000 Newton. So for 1000 Newton also, if I move the compass in the direction of downward direction, then here also anti-clockwise direction. So minus 1000 into perpendicular distance 150. Then we will move to the next 1200 Newton force. Now if I move the compass about the point O in the downward direction. So here is the clockwise direction. So here positive sign. So plus 1200 multiplied by perpendicular distance. So how to find out perpendicular distance? So if I extend this 1200 Newton force, then here is the point of intersection. So we will say this point is P and here this point is Q. Then this OP is the perpendicular distance. So in triangle OPQ, how to find out distance OP? So distance OQ is known 150 and it is nearby to angle 60 degrees. So its value is 150 cos of 60. So we have to take plus 1200 150 cos of 60. Now we will move next for this 700 Newton force. So here is the point of application. Now how to find out the perpendicular distance? So if we extend this line of action of force, then the vertical distance passing through point O is known as the perpendicular distance. So I will extend, here is the line, horizontal line, and from this point if I draw here, then this vertical distance we have to find out. So I will say this point will be X and this point will be Y. So distance XY is the perpendicular distance we have to find out. Now if I move the compass about the point O in the direction of 700 Newton force, then here is the anti-clockwise direction. So we have to take minus sign. So minus 700 into this distance XY. Now in triangle OXY, how to find out XY? So OY is known, that is 300. So this is the opposite to angle 60 degrees. So we can say that 300 sine of 60. So minus 700 into 300 sine of 60, which is equal to moment of the resultant. Now for this resultant Rx is also passing through point O. So there is no any perpendicular distance. So we can say it is equal to 0. Now what about Ry? So Ry is having perpendicular distance is X. Now if I move the compass in the direction of Ry, then here is the negative sign. So if we observe minus Ry into X, we have to take minus Ry into X. Now this Ry value is known, that is we have calculated, and we can put the value and we can find out this unknown value X. So value of X is equal to 141 meter.